Hi everyone. Okay, so my name is Tomasz Stańczak. I work on Flashbots team. Also work on a few other projects, including Nethermind. So this actually allows us to show you some of the prototypes today and some of the work that we've done in the past with Lido, with Nethermind, with Flashbots. And this talk will be on MEV on Ethereum 2. So while everything that we've seen before was either at this stage of being on testnet or already operating on a massive scale, MEV on ETH2 is obviously at the stage of researching, prototyping, and experimenting. So I think this one will be slightly more dreamy and going between different potential solutions. And if you want to follow the topic and look for all the other research and ideas that were here, so some examples would be at ETH Research, so Vitalik's proposal on the proposer block builder split. We'll talk about it a bit. Then ETH2 MEV with liquid staking. So the second one is the example of our prototype that we were building together with Lido and Flashbots and Nethermind for the ETH Global Hackathon. It was one of the winning projects. And MEV after the merge, so this is the talk from ETH Global presentations. And we explored there some ideas, and there will be at least one really fresh thing today that I hope that you enjoy. So as a reminder for some and a good introduction for others on what really differs before the merge and after the merge, where the merge is the merge of Ethereum 1 and Ethereum 2 chains, and acting no longer as separate chains, but as two parts of the system where one is acting as the execution layer and the other as a consensus layer. So Ethereum 1 becoming execution layer, delivering the blocks, building the blocks, validating blocks, and the Ethereum 2 beacon chain and validators acting as the block proposers and distributing them on the network. So now think about building blocks, selecting transactions, preparing blocks, and running all the state transition changes. But what changes after is how the block is propagated. So either we have the traditional proof of work, Ethereum 1 style distribution, and random statistical assignment of who will be the next block proposer based on the hash power, or the pre-selected validator that we often know a few minutes, 12 minutes in advance on who will be proposing the block. And maybe as an introduction, so MEV, minor extractable value, which you've heard about already, but why is it important in Ethereum 2? Because it massively changes the revenue of the validators. So this chart actually shows the comparison of the blue line, no MEV, and orange line with MEV, projected revenue of the validator operators. It's a huge difference of like almost twice the revenue flow. There's more detailed numbers you can find in all those presentations. They explored it in details. There were some numbers being run by Justin Drake, by Alex Obadia from Flashbots. So you can find this more detailed. But just to show that it will be a big deal because it massively changes the yields that are achievable in the system after Ethereum 1 will come to play. So maybe first the solution that was suggested by Vitalik on ETH Research. So let's look at it, how it works, and then we'll talk about two things that we explored in Flashbots and prototyped. So first thing is this proposer block builder separation. So you no longer have the vision of one entity acting as block builder and at the same time the one who distributes, proposes the block to the network. But those roles are split, and because they are split, there is suddenly some assignment that the block proposer is the one who is finding the MEV opportunities, and block builder is the one that finds MEV opportunities, and block proposer is the one who later publishes the block after choosing what MEV opportunity is most profitable for the validator. And the idea behind this block proposer, block builder separation was that it will be friendly for untrusted builder, which means you don't want to have the builders of the blocks that are particularly skillful or have to be trusted, have to be bigger than others, because you want to allow the small block builders to participate in the network. So you want to avoid this centralization of block builders. The second thing is untrusted proposer friendliness. So similarly, you don't want to have huge block proposers to have to be trusted, but you want to have lots of smaller block proposers to be equally accessible for the solution. For the weak proposer friendliness, so this is a similar requirement. And then we want to have some simplicity. Don't introduce too many layers over layers, commitments, reveals, slashings, and so on. We want this to behave relatively simple. And as always with MEV, one thing that we really care about is that the bundles, so the MEV opportunities that are being sent and delivered to by the searchers, the arbitragers, that they cannot be stolen, that someone cannot look at it and say, oh, actually, I'll just take it instead as my account, and I include it in the block. And this is a short visualization of those two ideas within the proposer block builder split from Vitalik. So one is assuming that the block builders are sending just the headers, commitments, payments to the block proposers. And then the block proposer selects the best of those headers, the one that promises the best MEV. And then the block builder either publishes the body or not. And depending on that, the fork choice rule changes. The body may arrive, may not, and the block is being broadcasted. The other proposal is slightly different. So the block proposer selects multiple different offered MEV bundles, chooses those headers that promise to pay to the block proposers, and then the bodies are being revealed, and then there is a second round where block proposer is selecting from among the few proposed headers that they committed to before. So they sign, okay, I will choose something from this list, and later when I learn about bodies, I can select one and say this is the one that goes to the network. And we won't really dwell much more on those two, and now we'll go to some ideas that were coming from the research in the Flashbot space. Just to introduce maybe once again, Flashbots. Flashbots has nowadays this system that provides a decentralized, democratized ways of moving MEV outside of miners only and miners private arrangements with the arbitragers, and provides the endpoints for searchers of arbitrage opportunities anywhere to connect to the network, send the bundles, and those bundles being delivered to the miners, and the miners including them in the blocks. And when you think about so far what has been achieved, like miners from these operations, miners got around $110 million already, and the total extracted value was probably around 800 million since the beginning of January. And over 300,000 blocks include on the mainnet in Ethereum the bundles delivered by Flashbots. And I think nowadays 85% of hash rate is Flashbots, 56% of blocks include some Flashbots bundles nowadays, and so on and so on. So those numbers are really, really quite significant on mainnet. And these organizations, I think it's very open with all the research. So if you are interested in participation in the research, there's lots of research opportunities published on the repo. So the first solution that was being explored was the very basic one. We may think of it like as a naive implementation of what works nowadays in Ethereum 1 and moving that to Ethereum 2 space. And we explored it as part of the ETH Global Hackathon. And that was being worked on together with people from Lido team and from Nethermind. So what happens here is you have the searchers that find arbitrage opportunities. They send it to Relay, and the Relay is the same Relay that operates nowadays in Flashbots. Is a centralized service in a way. It can be operated actually by independent relayers, but nowadays really there is one big Flashbots Relay that handles most of the connection with the miners. Relay collects the bundles, those MEV suggestions from searchers, sends it to the execution layer client, Ethereum 1 client, that simulates all the bundles, verifies how much revenue they bring to the validator, Then as part of this block processing, what happens is we launch something that is called Prism contract that splits the payment into multiple participants. And it allows the MEV value to be paid between the Ethereum 1 node operator, the staking pool, and validators. So stakers, validators, and Ethereum 1 execution layer, depending on the dynamics of how powerful they are in this cooperation. So we can expect that maybe stakers are the ones that should get the most of the MEV. Maybe it will be validators. Maybe it will be the actual block builder. Or maybe it will be searchers. So whenever we see MEV, there is this dynamics of who is managing to get the highest value, highest percentage of that MEV split. Even nowadays, it's a searcher miner. In this setup, we went for a most simple split of 1/3 to everyone, but we assume that this is something that market splits later. And after construction of that block, that is being pushed to the validator, and validator publishes it next. And I think I'll spend a bit more time on the second solution, which is practically something that we discussed recently and that we're quite excited about to explore. And we started building prototypes, and I think there is one prototype now in Nethermind repo, but soon there should be one on MEVGEF. And there'll be also coming probably somewhere after FCC an implementation on the Ethers.js Flashbots provider for this solution. So here, the whole idea is based on something that Jason Pariani proposed, which is using the dev P2P layer for distribution of the MEV bundles. And that's something that we wanted to do for a long time because it feels a bit more right than having this centralized relayer to push the bundles. We wanted to say, oh, the bundles could actually travel the same way as normal transactions. But we were thinking for a long time that traveling as normal transactions actually means kind of normal transactions. We have to provide EIP and introduce a new transaction type to deliver bundles. Why do we want to deliver bundles in some special way? Because we want to encrypt them for specific validators. So we're talking about Ethereum 2. However, later we realized that this solution can be also used even now in Ethereum 1, so we can start testing it very soon. The idea is the searcher knows in advance what validator will be validating the block. So they have a few minutes for that. They prepare the MEV opportunity, and they encrypt the bundle for that particular validator. And then, in a moment I'll show how, but they send it through dev P2P, and that's being picked by different nodes. But the particular validator that knows that it was addressed for them can decrypt it and include it in a block. And what comes together with this solution is that all the validators can register which block builders they accept, which block builders they are trusting, or which block builders satisfy the requirements on how to construct the blocks. And also coming also a bit based on feedback from the staking operators that there might be some arrangements where we want to construct the blocks in a specific way. Maybe not necessarily MEV comes first, maybe there is a set of transactions coming first before MEV, and these rules have to be consistent between validators saying, okay, these blocks are fine for me, and the block builder saying, I cannot really deliver any blocks to validators that won't follow those rules because of my arrangements. So how do we build the transactions that are delivered with encrypted bundles? So we introduce the concept of carrier transaction. And what carrier transaction does, it's absolutely normal transaction. It doesn't introduce a new type of transaction. It runs on the P2P network, and if we send it nowadays, it would be delivered to all the mempool nodes, all the nodes listening to mempool. Why? Because it has the sender, which is valid, it has a valid nonce, and it has a gas price that is covering the cost of transaction. So it's simply passing all the rules that the transaction pool would use for validation nowadays. And where is the bundle? The bundle is encrypted in the call data field, in the data field of the transaction, which means that you pay a bit more for the intrinsic cost of the transaction because all the bytes of the data have to be paid for. So it's a bit more costly, right? Because every searcher has to pay for each transaction they're pushing to the network. But it also solves many problems of the denial of service attacks on the relayers or the miners. So whenever you send a transaction, either someone will unpack the bundle for themselves and discard the shell. They don't even have to include this carrier transaction. Or potentially someone includes a carrier transaction and then maybe later from that block will extract the bundle and include it later. But there is really no chance of losing this transaction. It is paying for itself. And also, if we want to just flood the network, DDoS the network, then someone will say, okay, you're trying to attack it, so we'll include all of those transactions in blocks and we'll have to pay. And with the IP 1559, it means that as you start attacking, you'll be pushing the transaction cost up and up and up. And as for the construction of the blocks, so that thing that I mentioned on the how we create the registry and the validator says, I only accept these block builders, we can create a very simple definition of the how the block builder creates the blocks. You can say, this is how I build them. If you want as a searcher to send MEV to me, then maybe I will include first the section in the block space, which will be for a particular partner of ours. Then there will be Flashbots MEV or any MEV. Then maybe I'll include the mempool. And then something that we often talk about, like the second lane of Flashbots, which is privacy only, but it's cheaper because it's not MEV, it's just privacy. So I don't care to be in the front of the block, but I care about being private and not being published anymore. And this is just one example, and there can be a DSL that is publicly available, and everyone can, as a searcher, can verify if I'm okay to work with this validator, if I can find the connection of the validator and the block builder, which I want to use for sending the transaction around. Okay. And what else is big in MEV after Ethereum 2? So this is just a hint. This is some bigger exploration that will be happening and I will be researching for sure. It's a multi-block MEV. So nowadays, if you think about MEV extraction, it's all about looking at the mempool and maybe finding liquidations that are just about to happen, looking at the discrepancies in the pricing of multiple decentralized exchanges, finding opportunities to equalize the prices within a single block. But you never have a promise that that your MEV will work over 2 blocks because you don't know upfront which miners will include it. And also there is no transactionality in this. But in Ethereum 2, with a single validator pool or single validator registered in the registry, we can know in advance sometimes that they got assigned 2 slots in a row, that they'll be creating 2 or 3 blocks in a row, one after another, which means that suddenly we can deliver the bundles that say, please execute this only if you have 2 or 3 blocks in a row, and execute it such that this happens in 1 block, this happens in the 2nd block, and this happens in the 3rd block. And this has a potential of changing entirely some of the DeFi protocols, because they may simply fail in this environment. So what we've explored so far is some of the voting mechanisms may fail, like you can deliver the vote, initiate the vote, and then like win the vote always, and so on and so on. So I think many of the DeFi protocols will be analyzing that more deeply and checking what kind of changes and redeployments they have to provide to avoid potential negative impact of this multi-block MEV. But also it will be quite exciting to see what kind of positive impact the multi-block MEV can bring to the network. Maybe there can be some like periodical cleaning of some of the protocols that will happen every time this will appear. Okay, and these are my details. And I think here I'm very open to questions.
Are time bandits and reorgs still possible on ETH2?
So I think there is a very fresh piece of research from Georges and Vitalik about reorgs in ETH2 world, because the ETH2 definition of how you do the attestations or how you vote on the blocks make the reorgs much less likely or much less viable. So we generally assume that all this noise about reorg attacks or uncle-based attacks, this is something that mostly disappears or entirely disappears after the merge, and it has only has to be defended against while we're still using proof of work.
I have a question about ethical MEV. So some front-running are quite smart and are ethical and in the alignment with the Web3 ethics, but there is some MEV like sandwiching that is quite bad for the user experience. Does Flashbot have a position on that, or any plans to protect a bit the end user and the newcomers into this ecosystem who are using Uniswap or that kind of broadly used jobs?
Yeah, sure. So there are a few parts of it. Like, so one thing that can be unethical is more like interaction between miners and searchers when miners try to trick the system and steal MEV. Because with the current solution in Ethereum 1, it's still possible unless there are solutions like SGX. And the one way to approach it is by introducing the code of conduct for miners. And miners particularly care about the reputation of Flashbots nowadays. So actually this one slightly more centralized system that is trusted make it much more safer environment for searchers. This is one place. The other place is looking at the interaction between the searcher and the user of Ethereum, right? So searcher extracting the value together with the miner from the user by sandwiching, by pushing the slippage, and so on and so on. So obviously we see that as the categorization of the bad and good MEV. However, you can start thinking of what kind of problems it introduces when you try to introduce any algorithmical or even worse, manual approach of separating those two. Because you have to start labeling things as good or bad MEV. You know, like, is it an attack or is it a white hat trying to prevent an attack, right? Because algorithmically, very often it will look exactly the same. Like the white hat moving the funds to their wallet and then announcing that they secure that and then distributing back to the owner will look like an attack. The attacker might be harder to find. The sandwich is, you have to introduce some rules that can be then, you know, it's a constant cat and mouse chasing and replacing. So in a way, it ends up being feeling much more reasonable to stay neutral wherever it's possible, and assuming that the system, and slowly introduce whatever solutions that work and that can improve the quality of MEV, because it's clearly arbitrage that it's needed that makes the price discovery better operating, that makes all the DeFi protocols to be much more liquid, liquidations to happen, right? We want the liquidations to happen fast without delays, and so on and so on. But it's a tough problem to actually do that automatically. You say, okay, this is bad, so suddenly we are starting censoring things. Suddenly we start to be an operator, so it introduces all of the legal follow-up of why you actually act and say what is good, what is wrong. So yeah, it's a tough one.
Yeah, you're falling into the same kinds of critiques of some Web2 social networks that are canceling some politicians or figures, and yeah. But could it be community-led with a kind of DAO votes on which operation it could be, I don't know, more expensive to execute, or with implementing something more technical?
I think the best direction here to go is to make sure that the relay itself becomes a service that can be decentralized, that can be replicated and run by independent relayers that will offer different type of protection or decision making, or maybe introduce the DAO on deciding what is right, what is wrong, and what they pass and what not. I think one of the areas of research for us now, which is MEV SGX, allows for the relayer that can be much more trusted because by design it cannot leak the bundle information, which means the searcher remains safe even if they don't trust the relayer because they pass the encrypted bundle. All of this can be verified, then the miner can receive it, can verify it, start mining on it, and only after they deliver proof of work, also based on SGX, they can be sure that they will receive the actual decrypted body. Obviously, it uses SGX, which is also always a bit controversial and introduces some latency, but it's one area of exploration of like how to improve the general decentralization of the service by not requiring this trust layer that currently is with Flashbots. Just Flashbots, it has a lot of trust of both searcher and miner community, and that's why it achieved this like hash rate position now.
Yeah, I have a little follow-up question. So the fact that currently Flashbots only allow including MEV bundles to the start of the block, so it's a technical decision, not political one, right? So currently it disallows to extract, to do a sandwich attack using flash loans because no one can produce 2 blocks in a row, right? So if you allowed to include bundles not only to the start of the block but to some place of choice, then it could allow sandwich attacks. So is
as for placing the bundles wherever in the block, so the bundles construction actually allows you to include any transactions from the mempool within the bundle. So like the sandwiching is possible in this way. As for, it always happens within a single block. And we start to talk about multi-block MEV because in Ethereum 2 it becomes a big thing. Exactly, because in Ethereum 1 it's unpredictable who will be a producer of next block. Or maybe even we don't consider this like probabilities of the mining pools having so much of the advantage of producing many blocks in a row that this is relevant for Ethereum 1. But in Ethereum 2 it's quite clean. Yes, this will happen.
I see, thanks.
Yeah, just coming back on the multi-block producer MEV. So how could you prevent bad impact of multi-block MEV and how can you still allow good impacts of it? And what can you elaborate a little bit more on the good impacts you see?
Yeah, so I think whenever we construct a DeFi protocol and we think that like, oh, it would be great if I could ensure that it happens one block after another in some specific order, this would be probably good impact, but I wouldn't be able to just bring a good example. But I would love to collect those and hear those being like reported to Flashbots or any of the research materials. Like if you ever code something and you think that would work really nice if I had control over many blocks, this is the situation. As for how to avoid the negative impact, I think that's a bit like with flash loans. The community and the technology will learn how to build more robust systems and how to prevent this. And this will be like one more checkpoint when designing the DeFi, and one more thing that will make the whole thing more stable in the long term, right? Like because in a way, if we really push that far, someone could start to introduce the strategies like this with a lot of hash power even nowadays.
Got it, thanks.
Thank you. I was just curious, because obviously you guys are doing really amazing work, you know, in the open, in research, which is educating, and like you said, you know, app systems can try to work around making their systems less MEV sensitive and so forth. But how realistic, or I guess also just what sort of things are in the works from what you're learning to make recommendations at layer 1 protocol or layer 2 or any other things that could be a system, you know, that would, whatever extent, reduce MEV exposure, you know, even if it's inside of the pool of the, you know, Flashbots and not outside. So
some MEV exposure, I think it's just very natural and it will always be there. This is this arbitrage part where the markets get deregulated, and as simple arbitrage, it will always be there.
Yeah.
Any
And it's
any
actually, that
solutions-
arbitrage is considered valuable, right?
Yeah.
Because you're, you know.
Any
providing
like
service.
negative MEV, I think this will be coming with the solutions that built on top of Flashbots infrastructure, MEV infrastructure. So solutions like CalSwap or others who find a way. So I think it's all about what projects will surprise us and say, oh, this is how we solve the things. Like some kind of internal matching engines that avoid slippage on the protocols and so on and so on. So this education happens like showing searchers how to be more efficient, but also showing builders and sponsoring the hackathons and sponsoring the teams that are building on top of MEV, and particularly promoting those projects that show how to make the systems better and the bad MEV not to happen. Also, I think being very active and showing that as an organization that Flashbots actually really cares about the health of the protocol. So I think there's lots of consideration taken into account when we started talking about the reorgs and showing how much effort we put into showing what defense mechanisms can we build, how quickly can we realize, construct a research effort with top researchers that will tell how we defend, how much time we have, where we go next, what we should keep on the shelf just in case there are any of the reorg operations from miners and so on. Because we consider this is harmful for the protocol. Very deep analysis says we go this way, and it's like a negative sum game. Yeah, so it's a combination of the research effort, the research collective, inviting more researchers to the space, hackathons funding, and educating.
Yeah, I mean, one of the challenges for reducing MEV, right, is that it's definitely a public good. By definition, you're, removing money from the table that, somebody who's looking to build a business around.
Yeah, I think the community in the end, actually, like maybe people when they given like freedom of the protocol, then solo, they want to act as like, okay, that's laying on the table. But whenever we start talking about as a community on something that lays on the table, but it feels a bit more like a bad MEV, then as a community, we immediately will think about how to remove it. And actually, there's an agreement that anything that strengthens the protocol and makes it more desirable for users is actually something that is long-term valuable.
Yeah.
So I think this challenge, luckily, in this Ethereum community as it is now, seems to be something that we deal with quite well.
Thank you very much.
So I was just wondering about the latest thinking on multi-block inclusion in that sense, and what are the criteria that are kind of being considered as part of the same as part of the
Sorry, I cannot hear because
the multi-bundle inclusion. Sorry, as part of
multi-bundle inclusion.
Sure. Yep.
So that was something that was introduced in Flashbots version 0.2.
Sure.
And so what are the criteria of multi-bundle?
So I was just wondering, I seem to recall that it was almost being done on a greedy basis, if one might call it that, in terms of the inclusion based on the value extracted as well as the gas limits in some sense.
So
yeah.
it's more like quite a simple extension of a single bundle. So you compare the value to the miner of a bundle as compared to the tail of the block, and as long as the bundles keep improving the miner's revenue, they'll be included. However, the miner has a chance to choose how many of the bundles to include in the block and how much of the block space to take. And this really doesn't differ whether it's Ethereum 1, Ethereum 2. And as for criteria on in what order they have to be included, they cannot really affect each other. So it has to be that the first bundle doesn't cause any difference in the revenue of the second bundle. So they have to be like disjoint, and they sort it in it. And most of the miners will run something like 3 to 5 maximum number of bundles to be included in a block. Does it answer your question? Because I missed some
Yeah,
point.
I think it does. I mean, I was just wondering if there were any particular criteria or optimizations that were
There was lots of discussion. So I think
In-
hours and hours of discussions around how to store the bundles and how to simulate them, because it introduces latency potentially if sorted perfectly. But some naive algorithms actually were giving quite good results. So what's the latest one? The one that was applied actually brings some quite impressive improvement over. Like there was a lot of discussion recently about did the multi-bundle affect gas prices a lot on Ethereum? Did it bring the gas prices a lot down because of price gas auction participants not participating for the block space priority anymore, because they no longer had to hope that, no longer were fearing that if they miss the single bundle in a block, then for sure they'll be excluded, and that every single additional bundle in a block decreases the push for the gas prices growing because of those wars between different bots operating on the network. So I've seen some very convincing calculations on this ones.
That's interesting, yeah. It's especially about the simple optimizations being the best. So that's pretty cool. Thanks.
So are there any like concrete examples of MEV opportunities that can like utilize the multi-block thing? And then also, how is it guaranteed that both transactions will be included in separate blocks? Because I could see like ways that miners could exploit that.
So the actual construction doesn't exist yet. We simply mentioned that the multi-block MEV will be probably something big, and that we really invite people to explore it, research, and give examples. I think that one potential solution to ensure that both transactions are included is that you only make a payment to the miner if you can verify that the state in the second block is as expected after the first block. So one can introduce the conditional execution, and then the miner or validator can simulate both blocks in a row and check if that payment happens, and then they can compare the bundles. So it happens the same way as simulation of a single block nowadays in Ethereum 1. But in Ethereum 2, what will be needed, every bundle that spans over multiple blocks will have to be simulated over multiple blocks. And then it's guaranteed that the first one doesn't really provide any value if executed by itself, like doesn't unlock the opportunity. And there are some risks as the bundle will be split by the validator the same way as nowadays. Like the validator or miner could potentially split the bundle into chunks and act maliciously against the searcher, against this like code of conduct. But this remains unchanged.
And also, how much of MEV is going to the searchers versus the miners, and how does that like differ depending on the opportunity?
So this is an interesting question, because I was checking. There are two dashboards available for Flashbots. One is called explore.flashbots.net, and the other one is called dashboard.flashbots.net, and they show. They give insights into multiple statistics about the network behavior and also like the searcher operations. And I'm yet to confirm the number that I've seen today on this dashboard, because we introduced it recently, which shows 83% going to searchers. And I can't believe that, because in our internal conversations, there were totally opposite numbers. They mentioned that 7% goes to searchers and 93% to miners. So I wouldn't like to confuse you. This is something to check on the dashboards in the soon future, because many people are asking actually what the split is. And we really wonder what it will be in Ethereum 2, like how much of the value validators will take. My intuition is that the validators will end up with like 90x% of the value, but it might be different.
Cool. Does anyone else have a question?
Any other questions? Yeah.
Sorry, we just got here, so I don't know if it's been discussed. Why do you think Ethereum doesn't take steps to actually eliminate the miner extractable value?
I simply think it's not something that can be eliminated, because it's natural. It's like in traditional markets, MEV always exists. And as for this considered bad, evil MEV, which is related to the protocols allowing for the like sleepage push and so on, the community wants that to be removed, and there will be work to do that. It's just sometimes very challenging to remove it. So everyone wants it to be removed.
But it's not that challenging. If you think of some other protocols that mark transactions as they come in, so you don't let the reorder happen when they get picked up from the mempool. I mean, you could technically remove or at least limit it quite a lot. So
we've seen examples, and maybe coming to one of the questions before, like layer 2 and sidechains and so on. So on layer 2, there were approaches with VDFs and so on, like saying that the transaction ordering has to happen blindly and then it has to be followed. It actually leads to many, many other complications. There are like increased latency to the transaction execution. And also there is still some possibilities of generate multiple things in parallel and pick the best one. It's being explored. Yeah, well, like any research opportunity, like to give those further exploration. I don't think this is possible without big compromise on like the quality of the protocol and its swiftness and how quickly it operates. But things will be introduced. There will be multiple teams working on it and improving. And when we see sequencers on layer 2, they are centralized. They can extract MEV themselves, right? So does it mean that they remove MEV? No. I think we've seen this announcement now from Optimus saying that until decentralized, the sequencer on Optimus will be collecting MEV value and distributing it to the community, to protocols. A bit like putting it into charity on this like retroactive community funding, the public good funding. So these are examples of what people are exploring. They want to remove MEV, or at least they want to use it well by the time it's removed.
thank you.
Wow. That was quite intense. Thank you very much, Thomas.
Thank you very much.
So for the light kids in the classroom, unfortunately we have to wrap up. I think tonight was quite amazing. Hearing from SSV, decentralized validation on staking ETH2, from Lido, liquid staking, Vasily, and obviously Tomasz from ETH2 MEV and what's the future MEV on Ethereum. Again, like we are skills, we company that run validators on ETH2. We support Lido. We're one of the 9 providers supporting Lido, and we also staking for enterprises and any people that want to stake ETH2. And many of our team were here tonight, and I think we were kind of mind blown by what we saw. So I hope all the people in the audience had the same feeling. So thank you again very much for coming.